Good morning, students. Am I audible to you?
Yes, sir.
Okay. First tell me what are the characteristics of DC generator, or how many characteristics of DC generator are there? Tell me what are the characteristics of DC generator? Khushbu, tell me.
Yes, sir. Magnetization characteristic, internal characteristic,
Louder,
external
please.
characteristic.
What are the characteristics of DC generator? First, magnetizing characteristics or
OCC,
open circuit characteristics. The next one,
Internal,
internal characteristics. And the third one, It's
external.
external characteristics. Good. Okay. First, first, suppose I have a coil. Suppose I have a coil, and first we give a supply here by a DC. Suppose we give a supply here by a DC voltage source, and later on we remove that DC and make the supply AC. What will happen? Can anyone tell me what will happen? What will happen if we flow a current through a coil? Tell me, anyone? Tell me. You have to know that. Asghar, Asghar, do you know what will happen? Asghar Ali, suppose I have a coil, and first we give a supply of DC, and after that removing the DC, we give a supply of AC. What will happen? Or first tell me the DC voltage. See that the windings like what? There are three basic elements. We know that one is called resistance, another is inductance, and last one is capacity. You can say there are three basic elements. One is called a resistor, whose property is resistance. Another is inductor, whose property is inductance, and the last one is capacitor, whose property is capacitance. If we supply a DC to a coil, then the source will see that what is this? What is this? Tell me, anyone. Tell me. So the source, it is a inductor or resistor for DC. For DC, it is an inductor or resistor. Tell me.
Induct-
What?
Inductor.
Inductor. And in case of AC, is there any magnetic field create on that coil in both case? In both cases, is there any magnetic field? Suppose we have a coil and we supply a DC, then the current will flow through that coil and create a magnetic field which is in constant nature, and if we supply AC by AC source, if we supply by AC source, then it creates on that coil is varying magnetic field. And in case of DC, the coil behave as a resistor, and in case of AC, the coil behave as an inductor. You have understand that, Manish? Samsar, tell me whether you understand or not. Muskan, मान लीजिए आपके पास एक कॉइल है। इस कॉइल में हम पहले डीसी सप्लाई दे रहे हैं, फिर बाद में एसी सप्लाई दे रहे हैं। तो ये डीसी जो सोर्स इस कॉइल को किस तरह दिखेगा, और एसी सोर्स को ये कॉइल किस तरह दिखेगा? बोलिए। मनीष, टेल मी, am I audible to you? Manish, Manish, am I audible to you? Manish, am I audible? No, I did not hear you. Khushbu, am I audible? Khushbu Kumari? Yes, am I audible to you?
Yes, sir.
Okay. First, we are considering that we have a coil where we give a DC supply, and the coil behave like resistor. And when we give AC supply, the coil behaves like an inductor. And do you know what is hysteresis loss? Do you know what is hysteresis loss? Suppose I have a coil and where we apply a DC voltage, then the coil behave like a resistor, and the coil in case of AC it behave like a inductor. And in case of inductor, we make a graph. This is we are plotting I, and there we say the flux is going. First, when we increase the current, then flux also increase. Then after certain point, it becomes saturate, and what is the waveform of AC? Like that. When the current will increase, then the flux also increase. After that, a certain point, it becomes saturated. Then the value of current is decreasing. So please follow this path, and when the value of current is 0, let's say it is a point, this is B point, and then this is C point, this is D point, and this is E point. In first case, this is AC point, and then when the maximum value is reached of current, and this is B point. After that, when the current value is again 0, this is C point, and after that going back, and similar nature will happen and follow like that. This is D point and this is E point. After that, you will continue the same procedure. Have you understand how the actually this curve will generate? Manish, Manish, you are not audible. Yes,
Yes, sir.
it is now clear to you how the curve is
Yes, sir.
generated.
Yes, sir.
First, tell me, we are starting from which point? We are starting from A point.
Point A, sir.
Yes. Then, if the
Then
value of
point
current is
B.
increasing and goes to B, then
Then C.
it goes to B like that. And
Hello, sir.
if the current is increasing, then the value of flux also increasing, because flux will generate on that coil. And from A point, we go to the B point, and then we go to the C point. How? We are decreasing the current. After that, we go in reverse direction, then the peak will come, then after that we go to the E position, and it will continue the process. So a curve will generate of high, and actually this graph is in between phi versus the current which you have applied. So this curve is called actually hysteresis loss. Though in case of hysteresis loss, we plot between B and H. The hysteresis loss, actually, if we plot B in y-axis and if we plot H in x-axis, this curve is called hysteresis curve. And basically, B is I by A, that means flux density, and H is equal to Ni. So when we reach to the B point and when we decrease the current, and suppose sorry, no, sorry, I have a mistake here. The C point. Which one is C point? Because the current is zero here. Then this point is not. Which one is current 0 point? Tell me where the current is 0. This point. Have you got that? Which point current is 0? The current is start from that point. Am I right? Have you understand that? आपको कुछ समझ में आ रहा है? तो कोई
Yes,
कुछ
sir.
रिस्पॉन्स भी नहीं कर
Yes,
रहा है.
sir.
हाँ बोलिए. आपको तो बोलना चाहिए था यहाँ पर सर, वो जो करंट तो इस पॉइंट में जीरो हो रहा है, यहाँ पर थोड़ी ना हो रहा है। The point, the current is starting from that A point. That means the value of current is increasing, and if we go to the point where we go, actually we have to change the point of E also, because the current at the point C, actually at the point A, C, and E are zero. So this is basically E point. The value of current at A point, C point, and E point are zero. If we increase the value of current from A to B, that means from A to B, if we are increasing, then the value of flux is increasing also. Then after that, when we decrease the value of current and become zero, then the point comes at C, because here in y-axis the value of current is zero. And after that, if we go to the negative direction and we reach the maximum point or saturation point, which is D. After that, if we decrease again the current, or you can say uh, if we decrease the value of current, and when it becomes E, and this is the again in y-axis. So the value of current when the is zero, the value of current is zero. These are the A, C, and E point. And you can easily see that when the value of current is zero at that point, C point, the value of flux is something is there. The value of flux is not zero. This is called residual magnetism. This is called residual magnetism. तो समझ में आया क्या रेसिडुअल मैग्नेटिज्म क्या होता है? आयुष, कैन यू टेल मी व्हाट इज रेसिडुअल मैग्नेटिज्म?
सर करंट जीरो करने पे
बोलिए आयुष।
करंट जीरो करने पे भी अगर कोई मैग्नेटिज्म बच जाता है तो फिर वो रेसिडुअल मैग्नेटिज्म कहते
हाँ, if we decrease the current to the zero, then some magnetic field there, that is called the residual magnetism. Okay. And which point the current is zero? In which point?
हैं. So at y-axis, C and E
Yes,
and
good.
A.
In y-axis, not in x-axis. The value of flux is zero in x-axis. That means there and there, the value of flux is zero, not the value of current. And in C point and E point, the value of current is zero. So after that, we move to the next topic. Write down the next topic. Voltage buildup in self-excited generator. And next topic is voltage buildup in self-excited generator. This is our topic. which type generator is this is? Tell me, which type DC generator this is?
Self-excited.
Self-excited. And in case of self-excited, how many types of machine are there? How many type of machine are there?
So 3.
Three. What are these?
Series, compound, and shunt.
And which type this one? Which type this one?
Series. Shunt.
Shunt or series? Which one?
Shunt. Shunt.
Why you are saying that this is shunt? You are absolutely right. Why you are saying that this is shunt type?
So for field coil parallel में.
Because the field coil is in parallel with
Parallel. Amateur.
armature.
Armature.
First, we see separately two parts. Then after that, first we see separately two parts. Then we combine this and understand how the voltage is built up. Suppose this is field current and we are plotting in respect to EG. We are plotting EG with respect to field current. And what is the nature of that curve? What is the nature of that curve? In previous lecture I told you. It's like that. Am I right?
Yes, sir.
And suppose we are make a graph of resistance. How it will see? Suppose if we want to plot resistance in a car, this is IF because the IF is flowing through the field, and if we want to plot, uh, so if this is external and this is if we try to plot the curve of RF, what is the nature of that RF? What is the nature of the RF? Tell me. Suppose VF is that was the field current voltage. Suppose that. And what is the nature of curve of field current? Because the value of RF is equal to VF by IF when RF external is equal to 0. आपको ये समझ में आया? देखिए, have you understand my point? Yes.
सर एक बार रिपीट कर दीजिए ना.
देखिए इसमें क्या है, दो रेजिस्टेंस है, एक कॉइल. अभी ये सिस्टम क्या है, डीसी है एसी? ये जो मशीन है हमारा, ये डीसी है कि एसी टाइप है?
DC.
DC. Then the field coil behave like a resistor. I previously said that. जब अब अगर डीसी सप्लाई है तो कॉइल किस तरह बिहेव करता है? रेजिस्टर की तरह या इंडक्टर की तरह?
रजिस्टर की तरह सर.
रेजिस्टर की तरह. When we are considering the value of field resistance is RF and we add a external field resistance. पहले मान लीजिए the value of field resistance is 0. If we consider the value of external field resistance is 0, then we can say the value of field resistance is equal to the applied voltage across the field and the current flowing through the field. ये ओम्स लॉ की ये ओम्स लॉ से हम इस इक्वेशन को लिख सकते हैं. From the Ohm's equation we can get the RF is equal to V by IF.
Yes sir.
And if we plot VF and IF, then the nature of curve is like what? Like a straight line, because from Ohm's law we know that from Ohm's law, ये Ohm's law में हम देखते हैं ना, ऐसे होता है. वोल्टेज करंट को हम अगर प्लॉट करेंगे तो इसे क्या कहेंगे? फील्ड रेजिस्टेंस कर्व. हम इसे क्या कहेंगे? फील्ड रेजिस्टेंस कर्व. This is called field resistance curve. And now we change this quantity and making it the terminal voltage. Making it as terminal voltage V. And what is the value of where the voltage V is there? This is V. And here we can write the value of V is equal to VA, and you can say nearly it's EG, because the load current, the value of load current is 0 here. The value of load current is 0 here. So we can write the terminal voltage, the voltage across the field, and the generated voltage is near equal. So if we plot this same curve, then it's like that curve. This is RF curve and this is OCC curve. Have you understand that?
Yes sir.
क्योंकि हम दो ग्राफ को एक ही में प्लॉट कर रहे हैं. We are plotting the two graph. One is OCC curve and another is field resistance curve. Are plotting in same graph. Then it's like that. And what is the voltage build-up process? At the time when there is no field current. Suppose there is no field current, then is there any residual magnetism? If there is no field current, that is at the time initial time this field current is zero, is there any residual magnetism on the field?
Yes,
Yes,
sir.
yes or no?
Yes, sir.
Then due to this residual magnetism, if we rotate the armature, is there any voltage?
Yes, sir.
This voltage is called the voltage due to the residual magnetism. This is called the voltage due to the residual magnetism, and we denote this voltage by V0. And when the field current is zero and due to the residual magnetism some voltage is produced, the value of voltage is at that time is V0. And where the V0 is now come, they across the these two lines, the V0 is coming from the armature to that point. From these 2 points the voltage is now the value of voltage across these 2 points is V0. Due to the V0, some current should be, the value of field current, there should be some not like zero. And what is the value of field current at that time? We can get from this current. Due to the V0, how much field current is going? This much. The value of field current at that time is IF1. Due to the IF1, the there should be some flux which is should be additive with the residual magnetism. Though if the value of field current is now IF1, due to the field current there should be some flux which is generated on that field coil, and there is some residual flux. Though these are additive nature, then there should be voltage generated up to this level. And now the value of voltage is increasing. Suppose the value of voltage here is V1. Suppose the value of voltage here is V1. Now the value of voltage is become V1. Due to this voltage, the value of field current should be this much. Suppose the value of field current is now IF2. The value of field current is now IF2. So though the value of field current is increase, now the flux is generated on field coil is greater than the previous one, and so the voltage will goes up. So the voltage will goes up, and the value of voltage is now suppose V2, and the value is become now V2. And due to the V2 voltage, what is the value of field current now? This much. And due to this field current, the voltage should be here. And due to this voltage, the field current should be there. Then it's going to that point. Suppose this is the P point, and the terminal voltage finally reach to the P point, and the This is called the VT, and this is become now VT, and the value of terminal voltage is now becomes VT. Have you understand how the voltage is built up in self-excited DC generator? Have you understand? Is it clear to you now? Yes.
Yes, sir.
Ayush, is it clear to now?
सर ये V इज इक्वल टू VF इज इक्वल टू EG कैसे लिखिए सर? वो EG के तो बराबर बन जाना चाहिए सर, क्योंकि RA पे भी तो कुछ पोटेंशियल ड्रॉप होगा।
एक्चुअली क्या हो रहा है ये फील्ड करंट इसका वैल्यू क्या होगा? बहुत ज्यादा होगा कि कम? वैल्यू ऑफ फील्ड करंट is not like the load current. Suppose actually what we write, IA is equal to IA plus IL. If there is IL load current, then we can write IA is equal to IA plus IL, and the value of IF is very low with respect to IL. Uh, Suppose we have a machine with rated current of 40 ampere. Suppose we have a machine with a rated current of 40 ampere. At that time, the value of field current is 1 ampere or 2 ampere. So tell me, with respect to load current or armature current, we can neglect the 1 ampere or 2 ampere? Ayush, can we do that?
Yes sir, maybe.
Because the value of field current is 1 or 2 ampere and the load current is 30 ampere. So we can neglect 2 ampere with respect to 38. So we can say that the terminal voltage when the load is not connected, then we can say that the terminal voltage is equal to the or near equal to the generated voltage. इस तरह हम बोल सकते हैं. अच्छा, do you have understand the process or procedure of voltage buildup?
सर एक बार फिर से समरी दे देता सर।
ये फील्ड आपको ये जो फील्ड रेजिस्टेंस का समझ में आया? हम क्या कर रहे हैं, फील्ड के अक्रॉस में अगर वोल्टेज देंगे और कितना करंट जा रहा है उससे अगर प्लॉट करेंगे तो फील्ड करंट फील्ड रेजिस्टेंस का भी मुझे आएगा. ये हम ड्रा कर सकते हैं. तो पहले मान लीजिए हम एक वोल्टेज दे दिया फील्ड के अक्रॉस में और कितना करंट जा रहा है उसको प्लॉट किया तो एक रेजिस्टेंस कर्व आएगा. Suppose we are excited the field coil by a separate source giving the supply voltage VA, and due to this VA there should be some current flowing through the field, and now we plot the voltage current curve, so we get the resistance curve of that field coil. We get a field resistance curve, and what is OCC? If the terminal voltage or if the terminal is open, if we do not connect a load on terminal of DC generator, that means we can say This is a open circuit. Can we say that? Ayush,
Yes, sir.
if we do not connect a load on the terminal of DC generator, can we say that this generator is in open load or open circuit?
Yes, sir.
At that time, when we plot the generator voltage with respect to field current, we get a curve. What is the name of that curve?
OCC curve.
Yes, good. OCC curve. And what is the nature of that curve? Like that black color curve? Like
Yes,
the
sir.
black color curve. And these are the two separate actually curve. And in case of self-excited DC generator, how the voltage is built up, to understand this process, we have to plot these two curves in same graph. And at the time of starting, when we just start the DC generator, there is no field current. Is there any field current when just we start that machine or start that DC generator? Is there any current?
No, sir.
That means this is the 0 point position. The value of field current is 0. Due to the residual magnetism, there is some flux on field coil. Is it so or not?
Yes, sir.
Due to the residual flux, there should be some voltage produced on armature. There must be a voltage produced, a little bit voltage produced due to that residual magnetism. Yes or no?
Yes, sir.
Yes.
Yes, sir. V not on.
And yes or no? Have you understand that or not? Tell me.
Yes, sir.
Due to the residual magnetism, if the armature is moving, there should be some voltage whose value is quite low. But the value of that voltage at the time when the field current is zero due to the residual magnetism, there should be some voltage produced on armature. This voltage is called the voltage due to the residual magnetism, and this voltage is denoted by V0.
Yes, sir.
And due to this V0, and now what is the value of terminal voltage now? Tell me at that point, at the point of V0, what is the value of terminal voltage?
So V0.
At the time of V0, the terminal voltage should be V0 because
Yes, sir.
the voltage generated at that time is V0. So this voltage, due to this voltage, there should be some field current because this voltage is also across the field. Due to that voltage, there should be field current because this voltage is now across the these 2 points. Have you understand that, Ayush?
Yes, sir.
Then what will happen? Due to V0, we know from resistance curve, field resistance curve, how much current will flow. We know that from field resistance curve, and how much current will flow at that time due to the V0 voltage. How much field current will flow through the field coil? How much? Tell me. From the curve we get how much?
IF1.
IF1. Good. Due to IF1, there should be some flux which will create on field coil. If IF1 current will flow through the field coil, so there should be flux generated on that field coil. ये तो होना चाहिए, बोलिए। अगर फील्ड
Yes, sir.
फील्ड से थोड़ा सा करंट जाएगा तो थोड़ा सा तो फ्लक्स जनरेट करेगा, जनरेट करेगा कि नहीं?
Yes, sir.
If the flux is now additive with the residual magnetism, पहले कितना फ्लक्स था? रेसिडुअल की था, फिर क्या आया? ड्यू टू IF1 ये होगा फ्लक्स, ये पहले क्या रेसिडुअल मैग्नेटिज्म के लिए फ्लक्स था, फिर द फ्लक्स ड्यू टू द IF1 current. If these two flux are additive, then the flux is now increased from the previous one. If the flux is increased, then the voltage in armature also increase. बढ़ेगा कि नहीं? अगर फ्लक्स ज्यादा आया तो वोल्टेज ज्यादा होगा कि नहीं?
Yes, sir.
तो कितना वोल्टेज जनरेट करेगा? ड्यू टू IF1 how much voltage is generated at that time?
V1.
V1. Due to the V1 how much field current will flow through the field coil? Tell me. Due to the V1 how much field current will flow through the field coil? We are getting from
IF.
field resistance curve.
IF2.
IF2. Due to the IF2 how much voltage will generate on armature?
V2.
V2. Due to this V2 how much field current will flow? The next,
IF3.
like
Next.
that, and this process will going on, and when the curve, these two curve meeting point is P, and the final point should be P, because it goes like that and reach to the P point. Is it like so or not?
Yes, sir.
ऐसे करके तो ये P पॉइंट में आना चाहिए। फील्ड करंट फिर इंक्रीज किया, फिर वोल्टेज आया, बढ़ गया, फिर फील्ड करंट बढ़ गया, ऐसे करके P पॉइंट में आएगा। ये जो P
सर
पॉइंट,
इंक्रीज होना कब बंद होगा सर?
हाँ बोलिए फिर, मनीष क्या बोल रहे हैं?
ये सर वोल्टेज सर इंक्रीज होना कब बंद होगा?
ये जब P पॉइंट में आ गया, दो कर्व का मीटिंग पॉइंट कौन सा है? देखिए क्रॉसिंग पॉइंट कौन सा है? P। ये तो OCC कर्व है, OCC कर्व का एंड फील्ड रेजिस्टेंस कर्व का, दोनों का क्रॉसिंग पॉइंट कौन सा है? Where they cross at the point P, and this is basically the final terminal voltage, and we denote it by it Vt. And how much voltage will produce, or how much voltage at the terminal after the voltage build up, how much voltage will produce at the terminal? Ayush, tell me.
So VT.
Vt. That is the crossing point of OCC curve and field resistance curve. This voltage is the terminal voltage of the self-excited DC generator. ये समझ में आया? ये voltage कैसे build up हो रहा है? How the voltage is built up in case of self-excited DC generator? It is clear to you now or not?
Yes, sir.
Okay. Okay. Let's close today's class and go to the attendance part. Okay, you may leave now.